Guidelines for safety inspection of concrete and masonry dams. So, welcome to Construction Horizon. Today, we are going to study about guidelines for safety inspection of concrete and masonry dams. So, concrete dams. So, concrete dams include gravity dams, arch dam, roller compacted dams, buttress type dams, etc. So, what is gravity dam? Gravity dams resist the water force based upon their weight. So, gravity dams are bulky. Gravity dams are suited on rock foundations and occasionally on alluvial foundations also. So, gravity dams consist of maybe trapezoidal shape usually, and they resist the weight by gravity. Arch dams are best suited to sites where the ratio of width between abutments to the height of dam is not large, and when the foundation at the abutment is solid rock capable of resisting arch thrust. So, arch dam resists the water force by arch action, and the Idukki Dam in Kerala is a popular dam which is an arch dam. So, roller compacted concrete consists of roller concrete which is rolled. Roller compacted concrete dams are constructed with zero slump concrete using vibratory rollers and continuous placement methods. It has a surface cover of conventional concrete. So, roller compacted concrete, buttress dams. Bu- Buttress dams rely on sloping membrane, usually made of concrete, to transfer hydrostatic forces to the series of structural buttresses placed at right angles to the axis of dam. Buttresses dams are best suited for wide valleys with gradually sloping abutments. They can be founded on rock or sound alluvium. So, this is based on structural principles. So, masonry dams are built majorly on stone, brick, rock, or concrete blocks joined with mortar. Most masonry dams are older gravity dams, although a few are arch dams. Two methods are used to build masonry dams: placing shaped rocks of stone with mortar in the joints between them, and binding various sizes of rock or concrete together with mortar. Masonry dams are not currently used as they are excessive cost as compared to modern materials like concrete. So you can see in the picture it is the Perrier Dam, and it is having a shape which is gradually decreasing to the top, and uh, masonry dams repairs are very difficult, and it is requires a lot of precision. So dams encounter cracks and structural problems. Cracks may develop slowly at first, making it difficult to decide if they are widening or otherwise changing over time. Even if crack itself does not present a serious threat, the mechanism causing the cracking should be measured and documented during a visual inspections. Cracks are usually minor to major and requires various type of methodologies to treat. Let us study what are the types of cracks. Cracks majorly involves individual cracks, pervasive cracks. Pervasive cracks may consist of pattern cracking, decracking, check cracking, etc. Cracks are nothing but the locations where the stress is released. So, individual cracks or shrinkage cracks. Cracking of a structure or a member due to failure in tension caused by external or internal restraints. As reduction in moisture content develops or carbonation occurs. Shrinkage, shrinkage cracks generally occur due to loss of moisture after drying. So, when the concrete dies, a portion of the uh, concrete cracks due to shrinkage cracks. Individual cracks such as craze cracks are also common. So it is a maze of cracks with a fine cracking. These are may be attributed to shrinkage cracks. So in transverse cracking cracks develop right angles to the longer direction of the member. So this indicates bending. So blistering cracks, irregular raising of thin layer, frequently to 25 to 300 mm in diameter, the surface placed in mortar. Disintegration, reduction of surface to smaller fragments is normally caused by forces of nature such as wetting and drying, freezing and thawing, oxidation, decay, and erosive forces of wind and water. So, disintegration is common in dams. Diagonal cracks. In a flexural member, an inclined crack caused by a shear stress, usually about 45 degrees to the axis, or a crack slab not parallel to either lateral or longitudinal. Fine openings, pattern cracking, fine openings on concrete surfaces in the form of pattern resulting from a decrease in volume of material near the surface or increase in the volume. Pervasive decracking, a series of cracks in concrete near and roughly parallel to the joints, edges, and structural cracking in built without air entertainment technologies. Decracking is common. Pervasive cracking, checking, checkered consists of development of fine particles on the surface of concrete. The cracks show no evidence of movement, are shallow, and are closely spaced at regular intervals. These cracks may be several meters long and are typically caused by expansion and concretion of shrinkage of concrete surface with alternate wetting or dry period. Rapidly drying of newly placed concrete may be probable cause of pervasive cracks. Remedial measures. Damaged portion can be removed by and replaced by uh, by the deteriorated concrete and badly corroded steel reinforced bars. So first, the surface where the concrete is cracked is removed, and it is replaced by fresh bars and fresh concrete so and make it as good as new. Pervasive cracking or thermal cracking, cement hydration in mass concrete results in expansion. This followed by differential cooling and shrinkage of the outer is a major cause of thermal cracking. So, thermal cracking can be resulted from expansion. So, this is followed by differential cooling and shrinkage, and is major cause of thermal cracking. So, another aspect is alkali aggregate reaction and chemical sulfate reaction. Air occurs in two basic forms: alkali aggregate reaction and alkali carbonate. ASR can happen in concrete containing a cement having a alkali content greater than 0.6%, and glassy siliceous volcanic rocks are and potentially Deleterious rock types such as chert, opal, shale, and certain quartzites. Typical deterioration results in swelling and cracking of concrete. Remedial measures. These effects, if minor, can be repaired by removing the flawed concrete and replacing it with dry pack, epoxy bonded concrete. Some minor defects resulting from movement or failure can be repaired with surface grinding. So, these defects, if minor, can be repaired by removing the flawed concrete and replacing it with dry pack, epoxy bonded concrete. Some minor defects resulting may be repaired with surface grinding. Classification of cracks. So, the classification can be classified based on direction, that is longitudinal, transverse, vertical, diagonal, random, width 0.5 mm and less, medium 0.5 and to 2 mm, wide over 2 mm. Depth, measured depth. Consistent with the terminology used for cracking in embankments, some nomenclature for cracks in concrete dams differentiates cracks on parallel and the crest of the terms. Abutment and foundation. Cracks in the abutment and foundation of dam may signal a weak soil or a rock zone. Settlement from consolidation. Piping of soils or soluble rock from around or beneath the dam. An overstressing caused by seismic activity or the load on the of the dam and the reservoir. Foundation failure may allow the dam to start to move because of the force of the water behind the structure. Structural cracks, diagonal or random with abrupt changes in direction. Wide with a greater than 5 mm with a tendency to increase in width. Next to concrete that is noticeably displaced. Positionally narrow and diagonal, which signals an inability to handle shear stress. Long single or multiple diagonal cracks with displacement and misalignment. So, the remedial measure. Grouting can stop or reduce the seepage and piping, which should. So, you can see that there is a vertical displacement, and cracking. Grouting can stop or reduce the seepage and piping, which should end the settlement and fill voids in the foundations. Cracks needs to be repaired and monitored with the crack meters to measure growth. Seepage needs to be carefully measured. So, this is one of the aspects. Remedial measures. Transverse displacement. Repairs crack by filling with proper material that depends on the type, size, and extent of cracking. Install crack meters to check the continued development of cracking. So, here we can observe that there is a transverse crack. So, from that crack, the water can flow out. So, it has to be attended. Remedial measures. Cracks in abutments and foundation. Reduce seepage bar leakage through abutments or foundations by grouting or slurry cut-off walls. Monitor seepage bar leakage carefully to see if flow rates are increasing or after remedial measures have been taken, flow rates are reduced. If not, you take other remedial actions. Remedial measures. If significant movement has taken place and seepage is great, the reservoir level should be lowered at once. Buttresses, piling, and other structure may be needed to support the dam. So you can see here that due to the foundation settlement, the dam has tilted and there is a seepage of water from the toe end of the dam. So in this case, the water has to be reduced in the dam. If continued abutment movement is detected, the reservoir must be at once lowered to prevent further displacement. Geotechnical or structural measures need to be investigated to reinforce abutments. So abutments and foundations are very important. Here you can see that there is a crack due to the settlement of the abutments. So as the crack gradually increases, this may be catastrophic. Remedial measures. Movements needs to be monitored closely. Excessive movement can be controlled by construction of buttresses or added mass on the downstream side of the dam. So in this case, misalignment of the blocks is can be monitored, need to be closely monitored. Excessive movement can be controlled by construction of buttresses or added mass on the downstream side of them. So concrete cracking trend is extremely important to monitoring the crack. The trend of crack studying prior reports before inspection begins will enable an inspector to focus on how cracks have changed, that is, whether they have become longer, wider, or deeper, changed direction, or are changed. Documenting changes will enable future inspectors to do the same things. Measuring devices or reference points are sometimes. So, thank you for viewing this video. Hope you will be able to appreciate the remedial measures bar concrete dams and their maintenance. Hope you all enjoyed this video. Thank you for listening to this. Hope everything is good. Thank you.